Hello everybody, welcome back to my channel. Today we will do the Markov switching process. Okay. So the Markov switching model and the threshold autoregressive models, they are both used to analyze time series data with regime shifts, but they differ in how they model these shifts and their underlying assumptions. So, in the case of the Markov switching models, they assume that the regime shifts are governed by an unobservable Markov process, which means that the probability of switching from one regime to another depends only on the current state, not on the history of states. Here, the model can have multiple regimes, and the transition between them are probabilistics. Each regime has its own set of parameters, and the model estimates the probability of being in each regime at each point in time. However, in the case of the threshold autoregressive models, TAR models assume that regime shifts are determined by an observable threshold variable. When the threshold variable crosses a certain value, the model switches from one regime to another. Number of regimes. Typically, TARs have a fixed number of regimes, often two, and the transition between regime is deterministic based on the threshold variable. Here also, each regime has its own set of parameters. However, the switching is based on the observed value of the threshold variable rather than a probabilistic process. So today, we will start with the Markov regime switching model. Okay, so today we will try to see how does the kappa and beta vary over regimes. We like it is ideal that we subtract the fixed rate of interest, that is the 4% rate of interest, from our sectoral index. However, if we divide 4% yearly rate of interest by 365, since here we have daily data, or by 360, then the value is very low. So we are not carrying out that here. So as we know, the formula for the kappa and beta equation is Ri minus Rf equals to beta into Rm minus Rf. So here let us ignore the Rf term, that is the fixed rate of interest term. So here we are seeing how the kappa and beta is affecting our uh, our sectoral index. Firstly, uh, to do that, we will have to do a Markov switching process to see how, like, what is the duration of the sector to remain in a high volatility regime, and what is the duration of the sector to remain in a low volatility regime. Alongside, we would see that which regime is the high volatility one and which regime is the low volatility one. So after that, we will do a TAR model and carry out the cap and beta exercise. But before doing the cap and beta exercise, we would do the Markov switching model. Okay. So we would go to quick estimate equation. Here we would do a switching regression model. Okay. So the probability regresses. It is the probability with which y variable changes with regimes, and we would put only the constant term here, the c term here. Okay. The switching type would be Markov switching, because we are assuming that the underlying asset is following a Markov process. So here we are writing the list of switching regressors, and we are considering that C, that is the constant value, it is also changing regimes. In the list of non-switching regressors, we can put a lot of company specific or policy specific variables. And error variances should be regime specific. Okay. So here is our result. So from here, like just by looking at it, we cannot understand which regime is the high probability regime and which regime is the low probability one. However, we would uh, copy the data and put it in Excel and then continue with the analysis. Let us paste it here. Okay. So here, since it is given in a log format, so we would have to do the exponential to understand the actual value amount of the risk. EXP. So first let us take the log sigma of regime 1, and now let us take it of regime 2. Okay, so as we can see that the amount is more in regime 2, so we would say that the regime 2 is the high risk regime and the regime 1 is the low risk regime. So this is the first part of our analysis. However, for the case of the lag period that we've put one lag period. However, we should check the optimum amount of lag using the AIC check. Now we would go to view, and we would go to regime results, and we would go to transition results and get a summary. So this is basically the transition probabilities. Wait. So again, let us copy it to Excel. As we just learned that regime 1 is low volatility regime. So we would write 1 as low and 2 as high. As we can see, the probability that the sector starts with a low volatility regime and stays in a low volatility regime is 0.931, which is a very good indicator. And the probability that it starts with a low volatility regime and then it goes to a high volatility regime is 0.06, which is not a good indicator. And also the probability that it starts with a high volatility regime and then stays at a low volatility and then it moves to a low volatility regime is 0.38. However, the probability for starting at high and staying at high is even more, 0.61, which is not very good. And the duration uh, where it stays in a low volatility regime is 14 days, and the duration where it remains in a high volatility regime is 2 days. So, like from here, we can understand that starting from a low volatility, the sector stays in a low volatility regime with the probability of 93%. And starting from a low volatility regime, it shifts to a high volatility regime with the probability of 6%. So, we can do these kind of analysis from the transition probability matrix. Okay, now we can look at the graphs, view, regime results, regime probabilities, filtered, okay, and multiple graphs. Yeah. So the vertical axis here is measuring the probability, and here we have like the dates and the probability of the sector remaining in that regime, in a particular regime, within that date. So regime 1 is the low volatility regime and regime 2 is the high volatility regime, and these two are mirror images of each other. So this was our Markov switching model analysis. However, Markov switching model has a lot of limitations, and one of them is that we cannot have a deterministic threshold, that we cannot ourselves decide what is the threshold on the basis of which we would divide the regimes. However, the threshold autoregressive model solves that limitation, and in the next video, we would proceed with the threshold autoregressive model. Thank you.